Welcome once again to another video of this section where we are going to learn different aspects of Network Load Balancer and HTTPS Load Balancer and how to implement them from our demo application that's running on GCP's virtual machines. If you don't know what a load balancer is, from cloud's point of view, in simple terms, it's a software or a device that distributes traffic across a number of servers. And as the traffic is distributed between servers, the application that resides there becomes faster and fault tolerant. GCP offers a bunch of load balancers. However, in this video, we are going to focus mainly on Network Load Balancer and HTTPS Load Balancer. First, make sure you have set your default region and default zone from the terminal. I'm using US Central 1 region and Zone A. Now we will create a cluster of virtual machines. I've already created a script that each virtual machine will execute while booting up. What this script does, it installs Nginx web server and Git during the startup and also makes sure the server is up and running. This script also clones our web application from the GitHub on HTML directory. And before cloning that application from the GitHub, the script will remove any content that exists within the HTML directory. Then create an instance template that will use this startup script. Now we will create a target pool. If we don't know what a target pool is from the GCP point of view, then let me tell you. It allows a single access point to all the instances in a group and is necessary for load balancing for future steps. Then create a managed instance group using the instance template. It also says how many instances are needed for this group. In my case, I want 3 instances. You can choose more or less if you want. If we press enter, then 3 virtual machine instances will be created within a few minutes. We can verify the instances created with gcloud compute instances list command. Now, we will configure a firewall so that we can access our application on port 80 via the external addresses of those virtual machines. So, type in the terminal gcloud compute firewall rules create command, followed by the name of this rule, and also mention the port that needs to be allowed, which is in this case port 80. This firewall rule that we just created will be applicable for all the instances that are associated with the default network. Now we should be able to access our web application from the browser via their external IP addresses for any of the virtual machines we created. So our web servers that host our application are up and running. However, we don't want to access our web application directory through the public IP address of the individual virtual machines. Instead, we will access them through load balancer. So let's provision a load balancer now. In this video, we will experiment both with Network Load Balancer and HTTPS Load Balancer. Network Load Balancer allows us to balance the load of our systems based on incoming IP protocol data, such as address, port, and protocol type. To know more about network load balancing, please visit the official documentation of GCP. Creating Network Load Balancer is simple. Create a Network Load Balancer that targets our newly created instance group with gcloud compute forwarding rules create command. For this Network Load Balancer, region would be US Central 1, port would be 80, and also mention the target pool that we created previously. If we press enter, the Network Load Balancer will be created within a few moments. We can also verify our load balancer with gcloud compute forwarding rules list command. The output of the command also shows the IP address of the load balancer. Copy the IP address and paste it in your favorite browser. We will be redirecting to our demo application via the Network Load Balancer. So that's how we can create Network Load Balancer, and that will divert traffic across a number of servers that are sitting behind the load balancer. Now let's experience another type of load balancer, which is the HTTPS load balancer. There are a few advantages of using HTTPS load balancer over Network Load Balancer. HTTPS load balancer provides global load balancing for HTTPS requests as well. Apart from this, we can also configure URL rules that route some URLs to one set of instances and route other URLs to other sets of instances. Requests are always routed to the instance group that is closest to the users and having enough capacity and is appropriate for the request. If the closest group does not have enough capacity, the request is sent to the closest group that does have capacity. Now let's create an HTTPS load balancer. Creating HTTPS load balancer is not as simple as Network Load Balancer. We need to go through a number of steps to configure HTTPS load balancer. First, create a health check that verifies whether our instances are up and running or not. Then, define an HTTP service and map a port name to the relevant port for the instance group. Now the load balancing service can forward traffic to the named port. Then create a backend service with gcloud compute backend services create command. Specify the protocol for the incoming requests. Also specify the health check for checking the health of the backend service. Finally, add the instance group to the backend service with gcloud compute backend services add backend command. Also, create a default URL map that directs all incoming requests to all our instances. And then create a target HTTP proxy to route requests to our URL map. Now, create a global forwarding rule to handle and route incoming requests. A forwarding rule sends traffic to a specific target HTTP or HTTPS proxy depending on the IP address, IP protocol, and port specified. After creating the global forwarding rule, it might take a few minutes for the configuration to propagate. Check the load balancer we just created with gcloud compute forwarding rules list command. Copy the IP address of our newly created load balancer and paste it in the browser to access our web application. It might take a few minutes. If we are still facing an issue while accessing our web application, wait another few minutes, then reload the browser. So that's how we can implement load balancer to distribute traffic across multiple web servers.